Hey guys, how you doing? This is Mr. Chavla, and I'm continuing going over the August 2016 Common Core Algebra 2 regions. In the previous video, I went through numbers 1 through 6, and in this video, I'm going to be going over numbers 7 through 12. And again, this is Mr. Chavla, or Mr. C. Okay, so let's get started. I'm going to pull up the highlighter first. Okay, and let's use green. A set of data in the table below shows the results of a survey on the number of messages that people of different ages text on their cell phones each month. Okay, so the number of messages is this one right here in green, and then the ages, so these are all the text messages, 0 to 10 text messages, 11 to 50, and over 50 texts. Then the age groups are 15 through 18, 19 through 22, and 23 through 60. Okay, so let's read this real quick. All right, I'm going to minimize me, and I'm going to use yellow here now. If a person from the survey is selected at random, what is the probability that the person texts over 50 messages per month? So remember, that was the green part, the number of messages per month. I need the highlighter. I'm going to make this a little thicker. So text over 50 messages per month. So that's meaning it has to be in this column. Given, so whenever we see the word given, guys, that's conditional probability. Given that the person is between, and that's the ages, between age 23 and 60. So the general rule goes like this. The probability of A given B, the given, this bar right here means given, means it's out of the number of elements that's in set B, meaning it only includes the ones where B has occurred. And on top, so includes the number of elements that's in both A and B, because it can't involve anything that's not in B, right? So if we transfer this to texting over 50 messages per month, given that they're between 23 and 60 years old, it'll look like this. The probability that they send over 50 texts, right? I'll put that in green because that's the, no, we don't need to, because that's the first one. So get over 50 texts, given that they are between the ages of 23 and 60. I'll just put years old, and I'll put text here, so that I don't confuse, because then I start thinking, oh, over 50 years old. So if I use the same rule, right? On the bottom, it's going to include, it said between the ages of 23 and 60, right? So the number of people between 23 and 60 years old is going to go here. So I'm not concerned about anyone in the other age groups. So I'm going to add these three values, right? Now pause the video if you need to. I'm going to erase this so that I have more room. And again, this right here means given. So it's going to equal, we're only considering the ones that are between 23 and 60 years old, right? That's the age group. So we're going to add these three values, right? So let's add them real quick. 25 plus 47 plus 157. Is 229. So our probability has to be out of 229. That's the number that's 23 to 60 years old. Now, out of those, how many of them are 23 to 60 years old? And I'm going to move this down here, guys. This is all about conditional probability. How many of them that are over between 23 and 60 years old also send over 50 texts, right? So it's the ones that are 23 to 60 years old and send over 50 texts. So these are all the ones with over 50 texts, but I crossed these out, right? Because we're not concerned with the ones that send over 50 texts, and they're also 23 to 60 years old, right? It's 157. So the probability should be 157 out of 229, which we got right here in choice 1. All right, so this is, the topic is conditional probability. Conditional probability. So if you know conditional probability, this problem is no problem at all. So you want to make sure you know the different probability rules, and in this case it's conditional probability. Answer choice 1. All right, pause the video if you need to. We're going to move on to question 8. So I'm going to pull out the highlighter again, and they want a recursive formula for the sequence 18, 9, 4.5. Now if you look at the formula, first thing, you should see immediately that it's a dividing by 2 pattern or times 1/2 pattern. So it goes 18, they're using G for the uh, sequence. So the next one is 9. So I had to divide by 2, which is the same as multiplying by 1/2 or 0.5. Then if we repeat the same thing, we get 4.5 by multiplying by 1/2, right? 9 divided by 2 is 4.5. So the first thing you want to do is a recursive formula always involves stating the first term first, which is 18. G1 is the first term. And then there's a rule for what you do in order to get the nth term. There's something you have to do to the n minus 1 term. These two are explicit formulas, so they're no good. What do you do to the previous term to get the next one? You multiply by 1/2. So for example, if G1 is 18, then G2 is equal to 1/2. So I substituted 2 for n, right? Times G of 2 minus 1. If I substitute 2 for n here, 2 minus 1 is 1. And that becomes 1/2 of G1 is 18, which is 9. Then I could repeat the same way, right? 1/2, if n is 3, n minus 1 is 2, so G2 is 9, and 1/2 of 9 is 4.5. So that's why it's called a recursive formula. It's just saying n minus 1 is the previous term. So to get G3, I use G2. To get G4, I would just do 1/2 of G3, which is 4.5, and that, if I believe, unless I made a mistake, would be 2.25. So that's just the rule. So this is the recursive formula. The first term is 18, and then we multiply by 1/2 to get the next term. The mistake they made here is they got the correct first term, but they're doing a times 2 instead of a times 1/2 pattern. So answer is choice 1, okay? And you want to make sure you understand recursive formulas, and you want to understand the difference between arithmetic and geometric sequences. Now if you see no, you won't be able to see it, but my battery is really low, so I'll be right back in a second. I need to put in the charger. All right, charger's in, and I'm back. I now need to put the writing software back in here. All right, I hope that gave you a good chance to pause the video if you needed to copy everything down. I would encourage you to look up recursive formulas and explicit formulas, arithmetic and geometric sequences. All right, I'm going to move on to question 9 now. And let's get the highlighter tool back. And I'll use green. Okay, Kristen wants to increase her running endurance. According to experts, a gradual mileage increase of 10% per week, so we know it's 10% increase per week, that's exponential growth, can reduce the risk of injury. Kristen runs 8 miles in week 1. Which expression can help her find the total number of miles she will have run over the course of her 6-week program? Okay, so here's what we want to look at, guys. This is going to be, you know that it's going to be a geometric sequence because of the 10% increase per week. So that's a common ratio of 1.10. So the first term is the number of miles she runs in week 1. The second term will be the number of miles she runs in week 2. So A1 will be 8. That's the number of miles in week 1. And then to get, if we look at the, if we get if we want A2 or A3, we keep multiplying by 1.10. So our common ratio is 1.10. That's what we multiply by to increase by 10%, right? So here's what we're going to look at first. What we want is the sum of the first 6 terms of the sequence, right? So that means we want to do A1 plus A2 plus A3 plus A4 all the way up to A6. I guess I didn't have to write them all out, but I did now, right? These are based on geometric series formulas. So if I pull out the reference table, and you could have it memorized, the geometric series formula is simply the sum of the terms of a sequence. And I'm going to just take this, I'm going to capture it onto our screen. I'm actually going to capture both because we're going to be using both of these, and you'll see why in a second. But first, we're going to start off by using the geometric series, guys, because geometric series is the sum of the terms of a sequence, right? And don't need this. So we'll come back to this in a second. All right, the geometric series is the sum of the terms in a sequence, right? And the geometric sequence formula, all that's saying is what do you have to do to get the nth term? So to get a2, I would substitute 2 for n, where a1 is 8 and the ratio is 1.10, right? So we got the question. I'm gonna make this a little smaller for now. Okay, and we're gonna start with the series formula, right? So if I use the geometric series formula, that's the sum of the terms of the sequence, right? N is 6, so I want S of 6 equals A1, the number of miles run in week 1, which is 8, minus A1, which is 8 again. The ratio is 1.10 to the n power, but that's 6, all over 1 minus the ratio, which is 1.10. So these are the two formulas. So if you look, we got 8 minus 8 times 1.10 to the 6. So the top portion checks out, but the bottom, if I do 1 minus 1.10, that's not going to give me 0.90. That's going to give me negative 0.10 or negative 0.1, right? So that's not going to work. So choice 3 is out. And in here, we got 8 minus 8 times, this should have been 1.10 to the n over 1 minus 1.10, and they should have had 6 here, or even n, right? If you notice, up to 6 for n, so this is out. So what we're going to be doing is we're not going to be using the regular series formula. I'm going to hold on to this just to show you that we're going to get the same answer with the other method we use. So keeping in mind that an, so we're going to get rid of this, or actually I'm going to just, this time, just take the sequence, okay? So I'm going to erase this. Okay, and we know we're down to a 50-50 choice. The geometric sequence formula was given now as an is equal to a1 times the common ratio. I'm putting the parentheses in to the n minus 1 power. So to get the second term, I would do a1 times, which is 8. So for any term, it's 8 for a1, 1.10 for the ratio. So to get a2, I would substitute 2 for n. To get a3, I would substitute 3 for n. For 1, I would substitute 1 for n. It would end up being 8, and so on, right? If I want to do this, there's something called summation notation. I want the sum of an starting at n equals 1, but they said the 6-week training program, right? Going up to week 6. That's what we want. That's how this becomes a1 starting at 1 plus a2 plus a3 all the way up to a6. Now, instead of an, since an is equal to this right here, I'm going to replace this for an in the original one. So let's see if we could get this to look how we need it to look. So our final answer will have n equals 1. And instead of an, what I'm going to have is 8 times 1.10 to the n minus 1 power. So starting at n equals 1, going up to n equals 6, 8 times 1.10 to the n minus 1. That's what we want. Choice 1 is our answer. This one, they got the right thing in terms of 1 and 6 and 8 and the 1.10, but they didn't subtract 1 here. All right, so this was their error. So our answer is choice 1. Now I'm going to enter both these expressions in the calculator. I'm going to enter both this expression. Let me fix that. I'm going to enter this expression and this expression, and you're going to see that we get the same answer regardless, okay? So let's go ahead and do that real quick. So I'm going to clear this. The first one was 8 minus 8, 1.10 to the 6th. All divided by, and I don't need these parentheses anymore. I needed it so I could get the fraction. I don't have to delete it either, but just so you know what it'll look like in your calculator. 1 minus 1.10, it's about 61.725 miles, right? Now if I do the same thing using summation notation, now I don't know if summation notation is available in this calculator. If it's not, what I'm going to do is I'm going to go to a different calculator. It doesn't seem like it's here unless I'm missing something. Yeah, it doesn't seem like it's here. I'm going to just go to, not this one. Let's see if it's in this one. If it's not, then I know what I'm going to do. Because Desmos usually has everything that I need. So let's get rid of this. And what I want is I don't want this to take too long. I want to see if they have a summation notation here. I'm going to functions. Trig, no. Stats, probably not. Distribution, definitely not. Miscellaneous. Do you guys see summation? Here we go, summation. Love this. I love this Desmos, and it's free. Highly recommend it. So we start at 1, go up to 6, and it was 8 times 1.10 to the n minus 1, right? With n minus 1 being up. So I need to put parentheses, so make sure this stays in the exponent. And I don't need this parentheses anymore. Let's see if this works out. It's 61.724, about 61.725, which is the same thing we got here, 61.72488, 61.72488. So we got it, guys. It's choice 1. And if I were to add all those up individually, calculating all of them, I could do that too, but there's no point doing that. So our answer is choice 1. We're going to move on to the next question, okay? And this is about geometric series. All right? So you want to make sure you know that really well, and geometric sequences as well. All right, but it comes down to geometric series. Pause the video if you need to. I'm going on to the next question. Okay, I could bring me back now. There's room. Even though it's hard to see. Sorry. Okay, let's bring you down here. Get that out of the way. I want to make sure the window's as small as possible. It is. Okay, so, sorry if you can't see me as well. Okay, so I'm going to pull out the highlighter again. A sine function that is increasing through the origin can be used to model light waves. Violet light has a wavelength of 400 nanometers, and over which interval is the height of the wave decreasing only? Okay, so here's what's going to happen, guys. I'm going to first do a little sketch of the x and y axis. And I want to use black for the graph. All right, so we have our x-axis, our y-axis, and here we'll have our x-axis. So if it's increasing through the origin, that means it had to go up from the minimum. And then the midline, which is the average of the curve, is just the y equals 0. So I usually put the midline in here, right? Then the amplitude is just how much it increases. So it's increasing through the origin. That means it had to come up from its minimum to the midline, and then it had to continue increasing until it got to the maximum. So that means that its midline is the x-axis, y equals 0. And then one full cycle. So here's the only thing that is tricky. The only thing that's really tricky, so here we have our maximum, and here we have our minimum, right? So I'm going to trace in blue for the cycle we use. So this is a cycle right here. And typically we talk about in terms of period, right? Instead they're using wavelength, because period is used for time. Wavelength is used for distance. So the wavelength is simply the distance along one full length of a wave pattern. So the wave pattern would continue the same way, like this, right? So that's the distance of one full wave pattern, or equivalently the distance between two consecutive maximum or minimum heights on a wave, right? So they said that the wavelength, so instead of p, we use this symbol for wavelength. Not that it matters. 400 nanometers. I don't know the exact symbol for nanometers. And remember this, we always split the wavelength or period into 4 parts, right? So 400 divided by 4 is 100. So we're going to go by 100 nanometers. So from 0 to 100, it goes up from the midline to the maximum. Then it has to come back down to the midline. So this is where x is 200. Then it comes down to the minimum. And then it comes back to the midline when x is 400. So this is 300. And here it's 200, right? The x value. So here's what it's going to look like. They want to see where it's decreasing only. So if from 0 to 100, it's increasing, right? So 0 to 200, it's not strictly decreasing. So this is out. From 100, from x equals 100 to x equals 300, it goes from the maximum to the midline down to the minimum. So it's only decreasing during that interval. So our answer is choice 2. And let's just rule out the other possibilities. I'll use green. No, I'll use purple or black, because I don't want to mix up the colors, all right? So answer is choice 2. 200 to 400. It's decreasing until it gets to 300. but it's not decreasing the entire interval from 200 to 400 because as you can see, it also increases. And 300 to 400, it's only increasing. So that's out, and our answer is choice 2 because that's the interval where the height of the wave is decreasing only, okay? Where the height is on the y-axis. I don't know what the units are or what the height is. And the x-axis would probably be the I honestly don't even know what it would be. It's more something for physics. But number 10 is choice 2. The only really challenging part was that they use wavelength, okay? But if you know your trigonometry, it won't be difficult. I'm going to go on to question 11. Pause the video if you need to. And remember, the period of wavelength is always split into 4 parts, where it goes from midline to maximum, back to midline, down to minimum, back, and then back up to the midline. That's one cycle, because after that, the cycle repeats. So we're going to go on to question 11. The expression x cubed plus 2x squared plus x plus 6 is equivalent to, now we could do this by hand, but first thing, why don't we do this? If it's equivalent, they should give us the same answers regardless of the expression we put, right? So let's go in our calculators, and basically we have y1 is equal to x cubed plus 2x squared plus x plus 6 all divided by x plus 2, where we don't need the parentheses. I had to put it earlier so that they don't just put the 6 over x plus 2, but everything. And then all we have to do is since it's multiple choice, we'll enter a table and see which one gives us the same value. So I'm going to change y2 until we get the ones we want. So for this one, I'm going to enter a table. One way is to enter y1 and y2 separately. The other one is to do y1 minus y2, and you should get 0 for all the inputs of x, right? So let's start at -5. So you see that's not going to work, right? So we already know, since they weren't the same, we don't get the same outputs, that it's not choice 1. Now let's try choice 2. Choice 2 is x squared plus 1 plus 4 over x plus 2. So notice when I'm not putting it all in parentheses now, so that only the 4 goes over x plus 2. And if we look carefully, so far it seems to match up. Oh, this is how I get them to go like this. I was wondering how to get this to automatically go. I wonder if it works with the scale. But if you look, the x value and the y values, whenever you put the same x value, the y values are the same. So it's equivalent. That's the definition of equivalent. They're the same function, and I'll even go as far as to 5, and you could see that they're the same thing. I could even try decimal value, like 7 point. I just put a random decimal value, and it still worked. If I change it to negative, it still works. So we know these are without a shadow of a doubt equivalent, so the answer is choice 2. And now, what I'm going to do is I'm going to do this by hand, because this is about dividing polynomials, and you want to make sure you know how to do this either using long division or synthetic division. I'm going to use long division, and I would encourage you to look up synthetic division, okay? I'm not going to do that for this video, unless there's time. I'm going to see how long this takes. But what you want to make sure you have is standard form and no missing exponents. So the highest exponent is 3, 2, 1, 0. So we're not missing any, because if there was, we'd want to put a 0 coefficient in front. So for example, if there was no x, I'd want to put plus 0x. So we don't need to, so I'm going to put this here. And then we'll use synthetic division. I think we'll have time to do it, because there's not a lot more questions to do. So x cubed plus 2x squared plus x plus 6. And on the outside, we're dividing by x plus 2. Now it follows this pattern. What we do is we divide first, d, then we multiply, then we subtract. So the division, you always divide the first term, here it's x cubed, by the first term there. So if I do x cubed, if I do x cubed divided by x, that becomes x squared, because this is the same as x to the first, and I subtract the exponents. So that's what I'll put here. It doesn't matter whether I put it here or here, but now the next thing I want to do is when I multiply, I'm going to distribute. So I could either put it here, or I could write it out here, whichever way is more comfortable for you. Or, honestly, it's easier this way, but when you multiply, you're going to get x cubed plus 2x squared. And that's what you're going to write here. But when you subtract, you end up changing the sign, right? Because you're subtracting the whole thing. So it really becomes negative x cubed minus 2x squared when you distribute the negative sign. But you could see here that it's the same thing. Whatever's on the top is the same as what's on the bottom. So they're going to cancel out whether you distribute the negative sign or not, because x cubed minus 2x plus 2x squared, x cubed plus 2x squared minus itself will cancel out, so there's nothing left. So the next step, I guess you could say for B, is to bring down, right? So pause the video if you need to, or actually I'll just continue on the side. So it repeats, you bring down, and since it's a binomial out here, we also need a binomial down here. Typically, there would have been something left over, and it would be something plus something x squared plus x, but since that's not there, if I divide, I repeat the pattern. So now I'm going to do the same thing. Divide, multiply, subtract, and we do one full, so it has to, we have to complete the cycle. So the first term is x, divided by the first term of the other, of the outside is x, so it's just 1. So it becomes plus 1. So what I want to do now is, if you distribute the 1 over x plus 2 or multiply, it just becomes x plus 2, guys. Anything times 1 is itself. And then when you subtract, you distribute the negative sign and become negative x minus 2, right? This was x squared times x plus 2, right, is how we got this. So x plus 2, and then it becomes negative x minus 2 when we distribute the negative sign to subtract. And then we won't need to do this anymore because this cancels, and this is 4. That's our remainder. The remainder always goes over what we were dividing by in the beginning. So we want x squared, yes, plus 1, yes, plus 4 over x plus 2, yes. So that's our answer, choice 2, guys. I'm going to go ahead now, pause the video if you need to, and I'm going to show you a much faster way to do this called synthetic division. Okay, so pause the video. All right, make sure you have this all down. Take a screenshot if you need to. I'm going to clear everything. I'm going to do what's called synthetic division. So the first step again is to make sure that it's in standard form with no missing power. So 3, 2, 1, 0. Then what you do is you're going to make an upside down division box. The bottom is x plus 2. You set it equal to 0, and you find what value would make it equal to 0, and it's negative 2. So that's what's going to come out here. The coefficients are 1, 2, 1, and then the constant 6. So all you do is you write those coefficients in here, and this is going to work basically opposite of long division, where you just bring down first the 1, and instead of dividing, you multiply. So negative 2 times 1 is negative 2. Then you add 2 plus negative 2 is 2 minus 2 is 0. You multiply again, anything times 0 is 0, then you add, and you get 1. Multiply again, you get negative 2. 6 minus 2, or 6 plus negative 2 is 4. So this is your remainder, right? So we know that our final answer will have to have 4, the remainder, over what we were dividing by, which is x plus 2. Then this first one is a constant term, and since it's positive one, we'll put plus. If it was negative, we put minus. Then we increase the exponent of x each time. The coefficient is given as 0, it's 0x, and this is 1x squared. If we simplify this, we don't need the 1 in front of the x squared, so it's x squared. The 0x is just 0, so we don't need that, plus 1, plus 4 over x plus 2. So I find that to be a lot faster and easier than long division, and the more terms there are on the top, the more true that is. So we get x squared plus 1, x squared plus 1, plus 4 over x plus 2, and choice 2 is our answer. All right, so those were 3 ways to do it. One's using the calculator, but a lot of times they're going to ask you to divide it, and you'd have to use longer synthetic division, all right? Pause the video if you need to. So make sure you know how to do long division and synthetic division, right? And how to know when 2 expressions are equivalent using tables in the calculator. So we're going to go to question 12. Okay, I'm going to minimize me, pull out the highlighter, make sure that there's an appropriate level of thickness that works, and let's use green. A candidate for political office commissioned a poll. That's just a kind of survey. His staff received response from 900 likely voters, and 55% have said they would vote for the candidate. So 55 is for the candidate. So I'm going to write that right here. Basically, the N is the sample size. So 900 voters is the sample because it's not the entire population. And this P would mean population proportion, meaning the proportion of all voters who would vote for the candidate. If I put a caret or hat on top, that's the sample proportion. The proportion of the proportion of the sample of 900 likely voters is 0.55. That's 55% that would vote for the candidate. The staff then conducted a simulation of 1,000 more polls of 900 voters. So the simulation size remains at the number of simulations will not be used in any calculations, but the sample size is still 900, which it should be the same as what they did in real life, assuming that the population proportion, meaning 55% of all voters, That's what they're really trying to say here. When they say they're assuming that 55% of voters, they mean 55% of all voters in the population would vote for their candidate. The output of the simulation is shown in the diagram below. So they're assuming that the actual population proportion of all voters is also going to be 55%. And then they want to see, okay, in the simulation, what kind of results do we get, right? So it looks like it's a normal distribution, not exact, but approximately right. And let's see what we got. Given the output and assuming a 95% confidence interval, the margin of error of the poll is equivalent to, so we are going to assume a normal distribution. Unfortunately, they did not give us the mean or the standard deviation, right? And we don't need the mean. The mean should be approximately 55%, but we don't even need that. We just want the margin of error. So 95% confidence interval in a normal distribution is 2 standard deviations. So unfortunately, they did not give us a standard deviation because that would make it very easy. But the standard deviation, when you're dealing with a sample proportion and a population proportion, is simply going to be the population proportion used in the survey, which was 0.55. We're going to take the square root of everything. And in parentheses, we have 1 minus p, 1 minus 0.55 over, so I'll just put here, we're going to assume the mean. No, we're not going to assume anything. Forget that, guys. And on the bottom, the sample size goes in the denominator, and we take the square root of all parts. So the standard deviation is simply going to be 0.55 or 0.55. I'm just not putting the zeros because it doesn't matter, and it's harder to write that way, times 1 minus 0.55, right, all over 900. Now, the 95% confidence, when we're doing a 95% level of confidence, the margin of error has to be equal to 2 of those. So the margin of error, that's MOE, is 2 SD, 2 standard deviations, is equal to 2 times whatever we get in here, right? 0.55. If you could simplify and do 1 minus 0.55, you'll get 0.45. So 1 minus 0.55 is 0.45, but let's just say we don't even want to do that, right? In the calculator, all we have to do is find out what this value is. Don't round anything until the n, and the whole thing is being square rooted. So let's find out what that is, and that'll give us our margin of error. So our scientific calculator will clear everything. 2 times the square root of 0.55, 1 times 1 minus 0.55. We don't need the 0 here, we need it there, over 900. And it's equal to 0.03317-ish, so 0.033, right? Now they're rounding to 2 decimal places, so that's about 0.3. So 0.03 is the approximate margin of error. What that means is that we expect that this is about 3%, right? And they're expecting 55%. So we're expecting that 55 plus minus 3%, which is 52 to 58%. We're 95% confident that, what's going on here? Don't worry about this, guys. We're 95% confident that between 52 and 58% of the voters will actually vote for the candidate, right? And our answer is choice 2. So make sure you know, again, sample proportions, population proportions, normal distributions, 95% confidence interval, and margin of error, okay? Pause the video if you need to. That was the last question in this video. And in the next video, I'm going to be going over the next 6 multiple choice questions, all right? Let me come say goodbye. I don't like to leave without saying goodbye. Okay, bye guys. If you enjoyed the video, please hit like and subscribe. And please feel free to leave any questions or comments below, and I'll get back to you as soon as I can. And I'll see you in the next video. Good luck, guys. All right, let me close this off.